Today's video is about Dalton atomic theory. So these are the postulates of Dalton atomic theory. So matter consists of small indivisible particles known as atoms. Atoms are neither created nor destroyed. Atoms of the same element are alike in every aspect and differ from atoms of other elements. Atoms combine with other atoms in simple whole number ratio, forming compounds or molecules. An atom is the smallest unit of matter which can take part in a chemical reaction, and all chemical changes result from separation or combination of atoms. So this is about postulates of Dalton atomic theory. Difference between Dalton's atomic theory and modern atomic theory. So under Dalton atomic theory, atoms are indivisible and indestructible. So whereas here atoms are divisible and they are destructible. So atom is the smallest indivisible particle of the element. Whereas here atoms are divisible, it consists of subatomic particles like electron, proton and neutron. Atoms of the same element are alike in all respect and differ from atoms of other elements. Atoms of the same element may not be alike in all respect as seen in the case of isotopes, which are atoms of the element having same atomic number but different mass number. The next is electrons, discovery of electrons. So electrons were discovered by William Crookes in 1878. He found that when an electric discharge is passed through a tube containing gas at low pressure, blue rays were emitted from the negative plate, that is a cathode. These rays were called as cathode rays. So here the rays are being emitted. So it's a vacuum tube. So here this is a cathode and this is an anode. Vacuum, totally it is vacuum, and here cathode rays are emitted. So blue rays are emitted from the cathode. So these are cathode rays. Later, J.J. Thomson in 1897 studied the characteristics of constituent of the cathode rays. He found that the cathode rays, so some properties are there. So what are they? They travel in straight line, cast a shadow of object placed in their path, then deflected by magnetic and electric field, possess kinetic energy. So these are the properties of cathode rays. So from these properties, that is a conclusion. So cathode rays consist of negatively charged particles called electrons. Since atoms are electrically neutral, it must contain some particles which are positively charged. So mass of an electron. So mass of an electron is 1 by 100837 of the mass of hydrogen atom. So this is the deflection of cathode rays towards a magnetic field. So when a magnetic field, they get deflected. Next is discovery of protons. Goldstein discovered positive rays emitted from the anode consisting of positively charged particles called protons. If a perforated disc is used as a cathode, the positive rays may be seen traveling in the direction opposite to the cathode rays. So this is the anode. So this is a perforated cathode. So perforated means it's a plate with small tiny holes are there, and this plate acts as a cathode. So positive rays are moving away from that. So these are cathode rays. So now the conclusion. Positive rays consist of positively charged particles. So mass of the proton. So 100837 times as heavy as an electron. Next one is atomic nucleus. Rutherford in 1911 studied the atomic model and discovered the atomic nucleus. He directed alpha particles towards a metallic sheet. Alpha particles, the source is radium for that, and the metallic sheet is gold foil, 1/1,000,000th of a centimeter. Then the alpha particles are positively charged helium atoms containing 2 protons and 2 neutrons. So the deflection, now what happens? The deflection of the alpha particles was then observed. Here most of the alpha particles went straight through the coil, and few particles were deflected, and certain were deflected in angle, or some certain bounced back at a 360-degree deflection. So some are going straight, some are being deflected here, and some bounce back again. So now conclusions. The atom as a whole is relatively empty. So the positive mass is present in the very small region in an atom, and if the alpha particles not close to the positive mass gets deflected. So if the alpha particle passes very close to the positive mass, it gets deflected to the large angles. Drawbacks of Rutherford atomic model. So if an electron moves around the nucleus, it must radiate out an energy and gradually move towards the nucleus, following a spiral path till it collides and ultimately collapses in it. So thus, Rutherford model could not explain correctly the stability of an atom.